In question 8, we're given this quadrilateral ABCD, and in part A, we're asked to find AC, this length here. So we need to look at the information we've got. We've got an angle here, and here we've got an angle and a side opposite it. So hopefully this should ring a few bells that we are going to be using the sine rule, where you have A over sine A equals B over sine B generally. So here we are trying to find the side, so we would use the version of the formula with the side at the top. So if we put it in the context of this question, we need to start off by looking at the side that we have and the angle opposite it. So the side we have is 15, and the sine of the angle opposite is going to be sine 83, and we know that that is going to be this length here, AC, over sine 44. And if you rearrange that, you end up with AC is equal to 10.5. For part B, then, we're asked to find the area of triangle ABC. For this, we're going to use the formula half AB sine C, so the trigonometric formula for finding the area of a triangle. We have got this length here, AC, so we know this length here is now 10.5. We've got this side, so we've got two sides. At the moment, we don't have the included angle. So to find that, we're just going to do 180 minus this angle here, 83, minus this angle here, 44, and that is going to give us an angle of 53 degrees. So we do now have two sides and the included angle. So if we do half times this side, which is 10.5, multiplied by this side, doesn't matter which way around you do these, multiplied by the sine of the angle between them, that will give you an area of 62.9 square units. In part C, we are told that the area of triangle ACD here is half the area of triangle ABC. And from that, we're asked to find the possible values of angle theta here. So, first of all, we need to work out the area. So, if area ABC is 62.9, area ADC will be half times 62.9. And we know that, again, we can substitute that into the trigonometric formula for the area of a triangle. So that would be half times AB sine C. So A being one side, so half times A times the other side here, which we've already worked out previously, multiplied by the sine of the angle in between it, which is sine theta. So you can rearrange that and you end up with sine theta is equal to 0.998. We're asked, the question states, find the possible values for theta, and the reason it says that is because here we are looking at the ambiguous case. So if we take the inverse of sine, we can get 86.7, which was the one that everyone found. But of course, you could actually get another value, which is 180 minus 86.7 degrees, and that would give you 93.3 degrees. So either of those values could be possible in this instance. In part D, it says, given that theta is obtuse, so there should have been a bit of a hint there in part C. So if you didn't have an obtuse angle in part C, that should have rung a few bells that you needed to find the second value. So sometimes reading the question can help you with a question before. Anyway, we are told that theta is obtuse, so we can look back at our answer to part C and elicit that theta is 93.3 degrees. And we are then told to find length CD. So remember, we've already found AC, which is 10.5. We have got two sides and the included angle. So in order to work out the third side here, DC, we're going to use the cosine rule. So CD squared is going to equal 6 squared plus 10.5 squared minus 2 times 6 times 10.5 times cos 93.3 degrees, and that leaves me with a value of 12.4.